So I am Sandeep. Let us build up to our topic random variable. Let us begin with the probability definition. The classic definition is having the favorable outcomes in the numerator and all the possible outcomes in the denominator to give the formula. Its values will range from 0 to 1. If you put all values which are n, then you will get n over n and it will give you 1. So 100% chance certainty is given by 1, and if no favorable outcome comes, then you put 0 over n, the number of events. So heads have flipping a coin has got two events, so if we get one of the two outcomes, then this is the probability. So anyway, impossible events becomes 0. We have classifications of mutually exclusive events in which if we throw a coin, then it lands on either head or a tail, so it occurs separately. That's why it is mutually exclusive. Mutually non-exclusive event would be if a dice lands on 2, then we say that it is an even number multiple of 2, so two different things occurred together. Now that is a classification of experiment. Another can be independent event. So if we find the probability of pulling out a ace, it is 4 by 52 from a deck of card which has got 52 total cards, and there are only 4 aces, so probability to pick out a ace is this. It is an independent event. How it becomes dependent: if we try to find the probability of a second card to be ace without replacing the card, then individually that would be 3 over 51, reducing the total number of cards by 1 and the remaining aces being 3. So this is called conditional probability. The condition is that this is the situation and that has happened. If one has condition is that one ace has already been removed, what is the chance of second ace? Then the joint event also can be calculated as an extension to this conditional probability. That if what is the probability, if we ask ourselves what is the probability of getting two consecutive aces, so the first ace has this probability, the second ace has this probability. Consecutively it will happen as a joint event, so the probability will change and it will be given by this. Now there is another theory. The theory is Bayes rule, and Bayes rule uses conditional probability. Jointly an event can occur if A has occurred and together with this B has occurred, given that A has occurred in the consecutive or joint as a consecutive or a joint event. So this thing is Bayes rule. You rearrange them, replace the variables, rearrange them, you can get all this. So let us do an example using Bayes rule. In this question it has been given that there are 40% bad drivers, 20% good drivers, and the total population is having 30% bad drivers. So we have been asked to find the probability of accident in per year. So all these figures are given on yearly basis. So a bad driver has 40% chances of meeting an accident in a year. A good driver has got 20% chance of meeting an accident in a year, and so on. So how will we get the answer? We will get the answer which is to this question, that what is the probability of accident. So in the whole population we have got 30% bad drivers and then remaining 70% good drivers. So event of accident happens with bad drivers and good drivers. So 30% of bad drivers into the probability of having an accident will give you the accident per year for bad drivers. Then 70% times 20% will give you the joint event of having an accident for good drivers. So that is written here and done computed here. So this ends up our introduction to probability, so that we can dive into the next topic, which is random variables. One more thing I recall, there is this by Bernoulli trials formula. Probability of k successes in n trials and this formula can be used to compute case. Suppose for example we need to find the number of heads in n tosses, so 0 heads in one toss. How many ways, what is the probability of this event? It is 1 by 2. So it can be computed by plugging in the values of this event, this experiment, and you'll get the answer correct. And another test question can be, how what is the probability of getting just one head in two tosses? So in two tosses total outcomes can be how many? They can be uh, two outcomes. So one toss will give one outcome, another toss will give another outcome. What is the probability of having a head in that? So in two outcomes, one favorable event we need, and then we assign the probability to and the power to that probability, solve it, and we get something like this. So the old way was, without using the Bernoulli's trial formula, we would do total. We would generate a sample space, and then we would pick out the outcomes in which just one head comes. There are two out of these four. So again, it would give the same answer. But since we are trying to understand this formula, we can plug in the values here. So if we have two total tosses, then we want only one of our toss to give us head. Then the probability of event having head is 1 by 2. And how many what is the number of times that we want to have it to be have to it to happen is 1. And then 1 minus p is the probability of having head. Again, n minus k is 2 minus 1, which becomes 1, and that's how we get the answer. Now we are done, and we can dive into the part where we can discuss random variables. So what is random variable? If we flip a coin and then assign the outcomes to a variable, capital letter, the outcomes may be head or tail, and then reducing the complexity by just giving it a number, assigning a number. Now this number set, if this number set is assigned to this variable is called random variable. It is called random because we don't know what is the outcome of this experiment. We have a uncertainty. It can be head or a tail. It can be 1 or a 0. So this variable can take two values which are random due to this experiment of tossing this coin. So random variable is nothing but it is something mapping of uncertain outcomes from a sample space to a variable. Random variables can be of two types: discrete, distinct, or continuous. So these variables can take finite values, or it can take many values in a certain number range. So head and tail is a good example of discrete value. Tossing a coin can give us only two different values, two different outcomes. But if we want to measure a weight of an animal in a zoo, the weight of an animal in a zoo can vary to any amount. So in decimals, we can go to up to any precision level. So that is an example of continuous random variable. Variable can take many values. Other examples can be these, and you can think over them and they will fit in correctly to this classification. So probability distribution is the next topic. How do we do this? What is the meaning? We will get the idea through an example. Let us assign a random variable x, and what does x do is it maps the heads after three flips. So we'll do three flips and we will map the number of heads. So these are the all likely events that can happen, all possible events that can happen, and we want to map the number of heads. So the number of heads can be 0 when all are tails, all three flips results in a tail, or the number of heads can be 2, 1 and 3. So what is the probability of the random variable x taking a value 0? So x can take a value 0 when only when none of the three coins will have a head. So this is the outcome. So 1 over 8 is written because random variable will take a value 0 which is having no head on the three coins, on the face of three coins, that is having a probability 1 by 8. Similarly, what is the probability of having the random variable x a value 1? It would be 3 by 8. Why? Because there are only 3 cases in which the head comes or shows on just one coin. So that is the probability. So these are the probabilities computed for having number of heads equal to 0, 1, 2 or 3, and then we map this on a graph. So the number of heads can be 0, 1, 2 or 3, and the random variable can take these values with these probabilities, and this graph is called probability distribution graph. Why do we study random variables? Why have we included this topic in mathematics? The reason being that in our world we have a very unpredictable future. We cannot predict it. It is very random. So we need random models, stochastic or random models, to tackle the real life problems, world problems. So that's why we have got random variables inside, and it is probabilistic in nature. We need to think about or find what is going to happen, what are the chances of having a result. So that is probability theory, again attached to it. So outcome of an experiment, that that is classified as random variable. So basically it is the main ingredient of a stochastic model. Now let us see what is the difference between an uncertain event and a certain event. So basically a certain event is just counting the sides of a coin. How many sides does a coin have? It has got two sides, a tail and a head. Okay, that is a simple algebraic variable. In case of random variable, same set of values will be random when we think about the experiment that is being done. So the outcome of an experiment is uncertain, and those values, set values, become assigned to the variable, and that variable is called a random variable. Whereas when we just know what are the outcomes and assign the values to a variable, that becomes a simple algebraic variable. We discussed before, random variable has got two types: discrete random variable and continuous random variable, as shown. And these are a very clear pictured examples of discrete and continuous random variable. Does it mean if we write probability of capital X equal to small x? Here we mean that the random variable x is taking the value x. For example, in the case of our coin flip, the outcomes can be these. So the random variable x can take value 1, and what is the probability of this? It is half. Point to review is that the random outcomes of a experiment are called random variables. So if we throw a dice, then it can be mapped to these numbers. The variable, the outcome can be like these, and then this variable becomes a random variable. But again, this set of numbers, when assigned to a variable picked up from a number line, then these are positive numbers. So this is just a simple variable. So random variables are not equal to simple variables. How? Random simple variables are just values assigned to a variable, just picking up values, and the values that are outcome of an experiment are random variables. So hope I made sense. Another definition associated to this is cumulative distribution function. It simply means all the probabilities that take the values equal to or less than the given value x. So it is represented by f subscript x, random variable taking this value x, and it is equal to the definition, which is probability of taking of random variable taking the value less than or equal to a given value. So if we have a set of two values, head and tails, the probability of getting a value x less than this will be sum of both the probabilities. Less than or equal to means taking sum of both. Let us take an example. If we flip a coin, we have mapped the random variable 0 and 1 in ascending order. Let us have the purpose of giving them number is to assign them levels. So let us say 0 and 1. which actually does not mean it does not signify head or tail which one is bigger. Just the number will help us get cumulative distribution function. So probability of getting x random variable head is 1 by 2, and getting a head is also 1 by 2. Now we have this probability distribution chart which we saw earlier how to make, and this is it is how it is made, taking these two values at these probabilities, that is probability distribution graph. Cumulative distribution can be given by giving asking ourselves this question: what is the probability of x taking a value less than 0? It is just this much. What is the probability of x taking this or less than this much? It is sum of these two. So this graph helps us a lot in getting the understanding what is cumulative distribution function. So probability of x less than or equal to 1, less than or equal to this, so this and this included, gives us the cumulative distribution graph. How do we calculate it? How do we graph the cumulative distribution function graph? We first go for probability of random variable x taking a value less than or equal to this, which is 1 by 2. So probability of x like taking a value less than or equal to 0, which is say tails, is 1 by 2, and the probability of having a value heads or tails or less than 1 is sum of both, which is 1. So this is cumulative distribution graph. It is always increasing. Now we'll see these properties of cumulative distribution function are evident from our example. All the possible values will range within the set of values, and the probability less than an event will always be 0, or encompassing all events will be 1. Then CDF of this will be less than this if this is greater than the x1. So CDFs will differ depending on the events. So probabilities will also be different if we have events different, and all these are evident from our example. After cumulative distribution function, we have a definition of probability density function. It is different from probability distribution function. This time the distribution is replaced by density, so it is called PDF. So probability density function is nothing, actually it is something, it is differentiation of cumulative distribution function, which we have already studied. And now if we are going to differentiate this, we will spread out all the probabilities and it will result in displaying the PDF graph like this. It is represented as a small f. So the properties of PDF include that the PDF is always greater than or equal to 0, which means the PDF is always positive. This is so because you see the slope of this graph, the slope of CDF is always increasing, has a positive slope. So the positive slope will always have a value of PDF being positive. Secondly, if we have this differentiated to give all probabilities listed out on the PDF graph, and we integrate or calculate or sum up all the values, then all the probabilities values will end up as 1, or in a sense we can say area under this graph will be 1. So this is another property. We can give a range of values also to compute the probability of having a random variable x between two different values, so that will give us the value that we require. Earlier in my probability discussions short notes, I gave the value, I gave the formula to calculate expected value. So this is the formula to calculate. Another formula that you might need is variance. This is how you calculate variance, and you can do some examples and try and get a hold on these formulas, how to apply and get answers. This wraps up our discussion.